So we're going to go over the Siemens Mechatronics Systems Certification Program Level 1 exam. This is going to be test prep and study. I have not got my results back yet, so I don't know if I passed this damn thing. I can tell you it was an extremely hard test. So they gave us a mechanical transfer systems and drives kind of flow chart. They also gave us a fluid, a digital, and a electrical components flow chart. You should kind of take a look at these, and that will kind of give you an idea of all the questions you're going to have. Each flow chart little bubble on the bottom is going to have a question possibly on the test. You need to learn all this in about 3 months. It's kind of crazy. So we'll get into the actual questions here. We got maybe 50 questions. I don't know that I've got. Your test is going to consist of 2 hours, 60 questions, and it's a 50% pass rate, which at first, the first time you hear that, 50%, that's easy. Well, it's pretty difficult. The first test we took, I think most of the class did not get, they might have got 50%, but it was tough. And that was a super simple test compared to the rest. Most of the questions are not questions you're going to be seeing before, even in this test bank. Maybe 5 to 7 I had seen before. The rest were all new questions. And a lot of them are fairly difficult questions. So this is a pretty good representation of what you're going to see on the test is something like this. It's going to have PLC, couple of switches, voltage, control, couple control valves, the pneumatic cylinder, and a solenoid. And you'll have to diagnose what's wrong and where it went wrong. And frankly, that's hard to read that in 2 minutes and then process the information. So let's take a look at this first question here. So the pneumatic control circuit is in its initial state as shown below. Output Q5.3 is switched on. Cylinder 1A does not extend. As shown below, the following measurements are taken. What could be the possible cause of the malfunction? So there's quite a bit to go over here. Get a good logical way of doing it. You got to read the first little part of the question for sure, and then you need to figure out what's even possibly. So what I would do here is I would just pause each question, look at it, figure it out, and then I'll give you the answers on the question shortly. But I would not take my interpretation of any of this as correct. I am, a day ahead of you. I'm not that knowledgeable on any of this. So take it all with a grain of salt. Going through this has helped me though, so you might actually want to go through this yourself. So like here, looking at this question, what should I look for? We already said that 5.3 has power going out, so it's showing that it's good. So it should be making 1M1 contract, and 1M1 has 24 volts between A1 and A2. And then port 4, which is what goes to 1V2, our control valve, has 0 psi. So 1V2 needs air. If it doesn't have air, it's maybe not the problem. Depends on how you measured it though, so I wouldn't go crazy with that. And then cylinder 1A, well, it's not getting air because 1V2 doesn't have air. Okay, so where's my problem? I'm coming back near 1M1 and 1V1. Port 4 is not what I want it to be. So something didn't switch, or maybe something is being, maybe something's stuck in the solenoid, or the solenoid is powered up on the wrong side, wires are switched, who knows, but I'm going to 1M1 and 1V1 for this one. Sensor 1S2 is not even a consideration because that's on the far end of the extension. The cylinder is not extended. It's not going to trigger that. And then the controllable one, or the adjustable one-way flow valve, control valve 1V3 is a possibility because it's stopping it from extending, but it's not the issue because, well, port 2 having 60 psi kind of scares me. But I can tell that port 4 has 0 psi, so it needs air to push through that in order to go the other way. But that kind of tells me that there's maybe a switching problem with the solenoid. In my mind, may not be correct, but hey. So I'm going with A. And then here we have the slide telling us that it was A, so I got that one right. But you know, this is, don't listen to my logic, get your own logic for this. You know, you're going to have to be quick at these. You have 2 minutes to do all that, and you need to, you know, go on to the next one and dump that. And surprisingly, they came up with a lot of individual little questions. They're not all too crazy, but, you know, maybe there's a problem with the push button over there, or the stop-start button, or maybe it's a dual button setup. I mean, it's amazing how many different questions they could come up with that are all basically the same diagram, or, you know, close to it. It's, I mean, you do understand it at some point, but I'm not feeling like I'm totally there yet. But hopefully I passed this dang test. I still haven't got my results back. We'll see how I did, but I did not feel confident with the results. It was a brutal test, and I'm making this video after the fact so that if I did fail it, I will have something to review for my test prep for the next one. So hopefully this all helps you guys, and we'll go on to the next question. So here we have an easier question. We're going to have maybe 5 to 7 of these questions that you'll see, and you've seen them before. That'll come up on your test. I don't think this was one of them, but be ready for one of these fiber optic questions, though. I think there was one of those. Basically, anytime you've got the fiber optic line, it has to complete the light is part of the line. So if you cut the line, it's going to show up as workpiece present. You know, it's blocking the sensors. So just keep that in mind. It makes these pretty easy. And the other part of that is that, you know, it can't detect completely transparent workpieces. So here, it's not possible to detect a completely transparent workpiece. And E, a broken fiber optic cable at the light emitter is evaluated as workpiece present. It's blocking the reflector, or it's a break in the line, kind of the same thing. So another thing they went over was bearings. They had a kind of a lineup of 5 or 6 bearings, and they wanted you to know, or list each type, and they had them listed down the bottom. So cylindrical roller bearings, ball bearings, needle bearing, tapered roller bearings. I don't remember all of the ones they had in there, but go through and look through the different types of bearings, and don't use this picture. Go find more pictures. Your instructors might give you a certain picture that has most of them, but know the difference. And then also for your ball bearing, go look for, or just a plain ball bearing, go look at how that wire mesh goes together. They kind of give you a weird view on some of them. And then needle bearings, they don't need to be small like needles. They can be larger size bearings. So keep that in mind too. I was thinking needle was smaller bearings. I've never used a big one. But I mean, why couldn't they be 1-inch rollers for needle bearings? You know, if the bearing is a foot big, it might make sense. I don't know. But yeah, so that just gives you, just know your bearings and be able to say all of the bearings, not just one of them. All right, so for this type of question, you got 4 poles, so take your chart, milliseconds, there's 5 between it, 1 millisecond. How many milliseconds are in a second? Know that. I think it's 1,000. Don't use me for anything though. Go get your own information. And then you've got the 5, 12,000 divided by 4, 3,000. So I'd go with B in this case. But know how to do that, and do it fast. So B's your answer. Just know how to do that and know how to get there pretty quickly. This one took me way too long, or a question like this, it wasn't exactly, but took me way too long on the actual test. I probably wasted 3 minutes here when I should have wasted 30 seconds or 10 seconds. All right, which of the following statements about the functionality of the emergency lighting circuit as shown in the picture are correct? A, in the event of main power failure, the emergency lamp is not lighted. Well, that doesn't make any sense, right? You want it to come on. B, the lamp will be connected to the storage battery as long as the relay remains de-energized. Okay, so the power's off, it stays on. That makes more sense, so B's probably it. As long as the main power is available, it energizes the relay coil. So it's going to charge the pack. That makes sense too, so C. Since the relay coil is energized, the NC, normally closed, contact is open and the emergency lamp is lighted. So when it's energized, which means it's getting power, it's going to be on. No, that doesn't make sense. In the event of the main power failure, the secondary of the transformer keeps the battery charged through the rectifier. Well, if the power's out, it's not charging it. So that doesn't make sense either. So I'm going with B and C. Cool, so I got it right, B and C. But you saw how long that took me. That was over a minute for me to read it, digest it, spit it out, and that's a pretty easy question. So yeah, get quick at this and read it faster than I read it. Which statement about the mode of operation of the reflective light barrier shown in the pictures are correct? If no object is present, the reflector must absorb the light emission. Not really, because it's called a reflector. The interruption of the light beam by an object causes the output of the sensor to switch. That's probably true. Failure of the transmitter is evaluated as object present. So that's probably true. Failure of the transmitter is object not present. That's probably not true. And E, an advantage is it will transport. Well, that's not true. So we're going to go with B and C. All right, so the answers are B and C. Yes, you can see how long this is taken. I mean, that was still 40 seconds worth of me reading it and digesting it and coming up with the answer. I don't do it much faster when I'm silent and reading it myself either. So good luck with this and just get fast at them. I'm going to give you the rest of these questions without me talking, and you can go through them on your own. But there's about 40 more, I think. And I'll talk a bit when I think it's important. So this one you might want to know. I don't remember, though, if it was actually on there, but there's a couple of different versions of this question. I would know them. In general, though, I wouldn't memorize most of the questions. Some of the easy ones, yeah, but the more complex ones, they were different questions, and they actually kind of confused me in the end. Because I was kind of using the knowledge I had before and trying to decipher, oh, that's not even the question I'm looking at. I would just focus on getting the logic down on how these questions work and how to trace where the problem is. From now on, they're going to be 5 seconds each. Good luck. There's a couple versions of this question. I might pay attention to it. So they had a question kind of like this, but it was more about your multimedia readings as you got it, and I would study this question a little more, I think. So I would have this on my cheat sheet, and I would also have the Boolean truth table kind of thing. Should help a bit. The answer is C. So some of these I don't have the answer for. The answer key I had said this one was C, 24, but I felt like it was 0, A, but I guess it's 24. I don't know. You have to figure this one out on your own. So this one, the answer key I had gave it as a weird answer. I didn't trust it. You can figure this one on your own. I did not see this on my test, so whatever, but it might be in the test bank. So watch out if you get it, and I would research it a little bit or ask somebody that's smarter than me. So this is another one that gave me a weird answer. They didn't have it marked correctly, I don't think. But I'm going with C on this one. Check the cable between the PLC output, because the PLC is outputting for the extension of cylinder 2A, which is 2Y1, and 2V1 should be extending, but they didn't, so 2Y2 is the other side of it, so we don't care. 2V3 could be blocked, but it's not part of the question, so I wouldn't check that until after I checked the PLC and the cable. So I'm going with C. Ask somebody. All right, so different views of pneumatic cylinder are shown below. Okay, so what's true about this? So the piston forces exerted by the cylinder is dependent upon the air pressure, the piston diameter, cross-section, and the frictional resistance of the sealing components. Yeah, so A. And retraction force is higher than the extension? No. The extension force is equal to? No. The extension force is higher than the retraction force? So yeah, that sounds right because it's less diameter, less area. And then E, the larger the diameter of the piston rod, the higher the retraction force. No, that would make less area. So it looks like A and D are our answers for that one. So make sure you've got a table with the hexadecimal numbers and letters on it. Makes it all pretty simple. The answer to this one is B. And I think I used it 3 or 4 times during the test, so definitely have that table. And again, this one you might have seen before, or it might be a different one. 2 answers are correct for this one. So the set screw for the fastening carriage and impact shaft is loose, and the friction plates are set to loosely. No friction, no go. So this one I actually got wrong a couple of times. Looks pretty simple. So 1 is connected to 2, normally closed, and then 4 is separated. So make sure it says 1 on the bottom and 2 on the top, not 2 on the bottom and 1 on the top like C. So the answer to this one is A, and I really did miss it, I think, twice during testing. So this was a pretty common style question during the test. Make sure you understand the wrong answers on this one as well as the correct answers, and that might help you with the test overall. So the work program does not work on K1 and is never activated. So that's probably not true, because if I push PB2 and B1 is active, then I should get a K1. K1 is not activated when push button PB1 is pressed, and sensor B1 is not activated. Okay, so press KB2 or KB1 and then B1 is not active, it doesn't go. That's probably true. And then C, K1 is only activated when push button PB1 and PB2 are pressed. No, that's not going to work. K1 is only activated when push button PB2 is pressed and the sensor B1 is activated. Okay, well that will definitely work. So I'm looking at D for sure. And then K1 is either activated when push button P1 is pressed and sensor B1 is not activated, so that probably doesn't work. So that one's not good. So we're going with B and D on this one. So this one, another easy one. Electrical DC machine gets too hot during operation. What could be the cause? There's a malfunction in the cooling system. Yeah, that's possible. The load increased. Well, that makes sense. Yeah, that would make it do extra work, gets extra hot. Supply voltage broke down. That would mean less power going in. The load decreased. That makes it easier. The brush broke and have to be maintained. Yeah, well, whatever. Probably not it. So we're going with A and B. Which of the following statements about solenoids, and relays is correct? A solenoid is an electromagnetically controlled device in which the mechanical movement of a plunger is activated by magnetizing current. So yeah, that's right. So we're done. A. Which of the following statements about the gear train shown in the picture below is not correct? So it's like double negative or something there, I don't know. But the answer for this one is D. The rotation speed of the upper shaft is smaller, so it wouldn't be, it'd be higher, than the speed of the lower shaft. There was a question about like a ring gear, and then it had the actual small gear inside of the big one. And I would go look up some information on that. I did not see any of that in our study material and don't recall it. It asked a couple of questions, or it had four, it was a double answer one, and I don't know if I got that one right at all. So they did have a couple of these chart ones, not too difficult, but just make sure you're reading it right. 1.8 volts, 0.5 milliseconds, 2 kilohertz. D is the answer on this one. A block diagram of an elevator drivetrain is shown below. The elevator no longer reaches its maximum speed. What are the possible causes? Okay, so E, the cabin is empty, dumb. D, the transmission ratio of the gearbox changed, not unless somebody shifted it or broke down or something. C, the line frequency broke down. Yeah, catastrophic, but yeah, that could happen. B, the converter detected an overload current and reduced the output frequency. Yeah, that's possible. So C and B are correct. And then the ASM reached its operating temperature, which that's just its operating temperature. So again, just make sure you're looking at the wrong answers as well as the right answers. The electrical circuit diagram and the pneumatic circuit diagram of a control system are shown below. Which statements about the mode of action are correct? A, the piston rod of cylinder 1A is to advance when the push button S1 and S2 are pressed at the same time. Okay, well S2 is a normally closed switch, so it's already on. If you pushed it, that would kill the system. Basically an off button. So that's not true. The relay K1 with latching function is to be used for signal storage. Maybe. And then C, if the on and off buttons are both pressed at the same time, the relay is energized. Okay, that doesn't sound good. D, the piston rod cylinder 1A is to advance when the push button S1 is pressed. When the latching is released by actuation of push button S2, the piston rod retracts. Okay, that's going to work, probably. And then E, the signal storage is affected in the power section of the valve. I have no idea what that means. So no. So let's go with B and D for this one. So which symbol represents a pilot-controlled 5/2-way double solenoid valve? So a 5-port, 2-position double solenoid valve. So first thing I usually look for is the arrows. So D looks like the only one with correct arrows easily. That's 2-position. So it has 2 blocks on either side. Like B has 3 blocks, C has 3 blocks, E has 3 blocks. So the only 2 possible ones are A and D, but D is the correct answer because it has 5 ports. So which of the following statements about the circuit shown below are correct? A, neither the positive nor the negative terminal of the signal source VS is connected to ground. So VS, yeah, ground's in the middle way over there. It's not connected directly. So A is probably true. B, the circuit produces both positive and negative voltage from a single source. So VS is the source, so yeah, it's got positive and negative. Okay, so done, A and B. So go a little bit deeper into the other answers though, make sure you understand why. So voltages B and C are positive with respect to ground. So B is on one side of ground, C is on the negative side of ground. So that's not true. B would be positive, C would be negative. The voltage at point C is positive, so that we just said that was wrong. The B at point B is negative, that's wrong. So that explains why. All right, so this one's a pretty hard one. Well, I thought it was. I think I got it wrong. But basically it wants you to see what ladder logic is working here. So A, if push button S1 is pressed and push button S2 is not pressed, solenoid 1M1 is energized. So if we look over here to the right on the bottom, we see that S1 and S2 need to be pushed to get 1M1 to connect. So we can basically just jump to C. If push button S1 is pressed and push button S2 is pressed, solenoid 1M1 is energized. Boom. If neither push button, E, if neither push button is pressed, solenoid 1M1 is de-energized. So basically just looking at that ladder logic on the far right is going to answer all that question. The rest of it doesn't make sense. If you look at the other side, though, on the left, you could maybe think that that would work by pressing S1 or S2, but it doesn't. So a pickup cylinder 1A moves downward completely, which is necessary for the gripper to be closed. So it has to go down to close. If the gripper fails to close, what are the possible causes? It didn't go all the way down. So A, sensor 1B2 is not triggered to detect that the pickup cylinder 1A has reached its downward end position. Okay, so let's see 1A over here on the right middle kind of area. 1B2 is the end sensor for down. So yeah, that looks like that didn't happen. Okay, so A. And then if we go to D, flow control valve 2V3 is completely clogged. So the gripper needs to go from on the right side there, 2A, needs to go from open to closed. It moves forward to close it. So that means that it has to be able to let air out of 2V3 in order to do that. And the ball check valve there is going to be going the wrong way for that to happen. So that is the answer. A and D. All right, for this one, anything with a spring, so you can see the zigzaggy line, that's showing that this has a spring return, is going to need a negative. So B is the answer. The 10, because piston A is in centimeters squared, you just know that that gives a 10 in the formula. So that means it's B, C, or D. And since the only one that has a negative is B, B is our baby for those three. I would definitely look at all the wrong answers on this one. The seed of a synchronous machine is higher than written in the data sheet. What could be the reason? The answer is B. The frequency of the three-phase voltage is too high. But like I said, I would go look at the amplitude of the three-phase voltage is too high. What does that mean? The load connected to the machine is too small, so that's not going to cause that problem. The load connected to the machine is too high. I would probably say that's a possibility, right? I don't know. The excitation of the machine is too low. I think that means it won't even start. But yeah, it'd be worth looking into the wrong answers on that one just so you understand those. And then the frequency of the three phases voltage is too high is the correct answer for B. So find out what a contactor is. A 24-volt DC contactor controls a three-phase AC motor, 230 volt / 400 volt. Which of the following measurements are correct? So A, contactor activated 400 volts between terminals 1 and 4. Sure. B, contactor activated 400 volts between terminals 1 and 6. 400 volts. Sure. Oh, negative 400 volts. So yeah, that's true. And then C, contactor not activated, 400 volts between terminal 33 and earth. I don't see a terminal 33, so that's not going to work. D, contactor not activated, 0 volts between terminals 3 and 5. I have no idea. E, contactor activated, 230 volts between terminals 1 and 2. So 1 and 2 should be, I have no idea either. But the answer is A and B, and you should go talk to an electrician if you want more information on this. I wish I knew more on it, and I did talk to an electrician, but I still didn't understand it. So this is kind of a safety first kind of question. So, and if you don't want me talking, just mute the volume. Pause these questions as you want to go through them, and you can write down the answers or something. Maybe I'll put an answer key in the bottom here, link it. That might be kind of difficult though, but we'll see. But yeah, the answer for this one is D. Tell the person responsible to buy a new one and do not use the machine until it is fixed. If I was in a real job and I'm working, I might do E. Tell the person responsible to buy a new one and use the machine as normal as you monitor it carefully. It depends how much money I'm losing by having this machine shut down and what risk there is of some kind of an issue when it does break or if it does break. I don't know. But D is the correct answer. As shown below, the LED display connected to a PLC output module enables the machine operator to view the number of workpieces produced. Which of the following statements about the display are correct? A, the LED displays the decimal form of a binary coded decimal value, BCD. Yeah. B, to display the next higher number, in this case 39, only the PLC output QX.0 must be changed to a 1. So currently it is 0, 0, 1, 1. You can see that under the 3. And then for 8, it's 1, 0, 0. And then for 9, you would have 1. So 1, 0, 0, 1 is 9. So over here on the far right side of this question, there's an SFC chart, systems function chart. Know what each one of these little boxes means. So the extended cylinder 1A, that box is the command one, and then 1B2 is the result or the what box. You might want to know that. Okay, so the clamp gripper extends, fails to close. Okay, so E, inductive sensor 2B2 is no good, so E. And then D, port 5 on 2V1. 2V1 is down here on the right. Hard to see, I know, I'm sorry. But the air coming out of the gripper when it goes back to closed, because it's open and closed, that's not allowing air to escape, so it can't close. So D and E are the correct answers on that. Right, and then here is another look at that one with the 1 goes to 2, normally closed, and then switches to 4. So you can now see that C is incorrect because it's 2 on the opposite side of 4. A is the correct answer, and I got that wrong numerous times. Moral of the story is try to learn from your mistakes and not pick the same one over and over. All right, so I found this picture online. I kind of like the top 3 where it goes over the and nands and or and nor and XOR and XOR and XNOR. But it's a little too confusing for me to read it. I put mine into each one. I had them coded like he does on the left. And I also had a Boolean table, so I had the Boolean calculations on there also separately from this. And then I did see something on the test that was kind of like the far right, but it was not to do with AND gates, I don't think. But if you have that little table, then you can go over questions like this. So which of the following statements about NAND gates are correct? If all inputs are 1, then the output will be 1. So it's not AND. So if it's 1, 1, that's an AND. If all inputs are 0, the output will be 0. No, that's an AND also. If all inputs are 0, the output will be 1. Yes, that's true. If 1 or more inputs are 0, the output will be 1. That's true too. So C and D are true about NAND gates. And there were a couple questions on the test. I don't remember what they were, but they did have a little bit of that going on. So it was nice to have your NAND gates. And then also you needed a Boolean table. Make sure you have a complete Boolean logic table, like true, false, false, true. I'll put a little picture up here in the next slide. But if you want to know when one or both matching bits in 2 different words are logic 1, you would use the, so it says 1 or both, so B, or gate. So this is the other question about the car window thing. So the answer to this one is A, increase in VR, B, increase in iMotor. The other one, I think the answer was decrease in R, which gives you an increase in iMotor. So just thought I'd throw that one out there. All right, so which of the statements about the mode of operation of the control system as shown below are true? So the retracting movement cylinder 1A is adjusted by the flow control valve 1V3. That's possibly, I mean, they kind of do adjust a little bit both ways because that's the air going into it. So that's going to push it back, but the flow control valve is going to be going the other way. The check valve is, you can see where it hits hard. So 1V2 is going to be the one that controls the flow. The air pressure will come in through 1V3, but the actual flow out is 1V2. B, the retracted end position of cylinder 1A will be triggered by sensor 1B2. So retracted, this is extended would be 1B2, so that's wrong. C, when the PLC switch back from 1 to 0, remains in the current position. So if you go look at the solenoid down here, it has a spring on the right side, so it doesn't remain in a position when it switches. It goes back to the original position automatically. So that makes D and E the correct answer. And E, maybe explain that a little bit. So 1B2 is over here on the right side, and then the sensor that they're showing in an exploded view is on the left side also, and it goes into input 5, which then gets 1Y1 and 1B1 moving. So pretty easy on that one once you just think about it. All right, so there was one question on the test that was some kind of weird, I don't know what it was, and it wasn't even look like this, I don't think. But it was asking between one A, B, C, D, E, which one was true and which one was right. And I was like, I have no idea what it even meant. But the table looks something like this, so figure that out on your own and go find a Boolean truth table and see if you can make heads or tail of it. Maybe I didn't read something in the question, but I wasn't even sure what the question was. Having something like this on your thing might make sense too if you understand what it's saying, but you'd have true and false would be 0 and 1. And then here's that delta thing again. We had something like this, star pattern, I don't know what it is. And then also PLAC program scan cycle. Logic gate symbols, kind of already went over that you should have the logic gates, but you should also have the little table of each one. Definitely have your circle somewhere on your cheat sheet. Here's a contactor. You know, I was like, what the hell's a contactor? Relay, contactor. I don't have a picture of a solenoid, sorry. Boolean notation, also have that and the table, so you know all that. And then here's a function chart, system function chart, SFC. The acknowledgement there's there on the end. Yeah, so I don't know, just having the acknowledgement field down. They might have called it something else too. I don't remember what it was called, but command field, transitions, step field, transition condition. Be good to know that. So yeah, thanks for watching. I've got a few other little slides here of things you should maybe have an idea on. This is that star and delta thing. I don't know. I got that one wrong. Probably have my sensor symbols definitely written down. Maybe a couple solenoids, especially the 5-way one. That would be the good one. Five port, 2 position. Bearings, just know them. I kind of like this picture actually. That one would probably be handy. Didn't have any of this, but it's good to know your resistor stuff. I had it on my chart, just a little quick thing, and then definitely have this guy on there. But thanks for watching, and have a good one.